Welcome to This Explainer. I am so pumped you're joining me today because we are unpacking something literally every single one of us has experienced. We're going to reveal the fascinating science, the extreme history, and the deep-rooted human psychology behind why things just seem to inevitably go wrong. That's right, we are dissecting Murphy's Law.
So let me ask you, is the universe out to get you? Think about it. Have you ever felt personally targeted by the cosmos? You know the feeling. You're rushing out the door, you bump the edge of the kitchen table, and bam, your breakfast drops. In that split second, it really feels like reality itself has completely conspired against you, doesn't it? It's a totally universal feeling, but as we're going to see, it is entirely grounded in hard science. And that exact feeling is perfectly summarized by one incredibly famous adage: if anything can go wrong, it will. This right here is the absolute core definition of Murphy's Law. It's an idea that's basically permeated our entire culture for decades. But to really wrap our heads around how this law works in our everyday lives, we kind of have to look at its most famous and, let's be honest, most annoying manifestation: dropping a piece of buttered toast.
Okay, let's jump right into Section 1, the buttered toast phenomenon. For years, scientists literally just dismissed this as a myth. They figured, hey, if you flip a piece of toast, it has a 50-50 chance of landing on either side, exactly like a coin toss. But then, physicist Robert Matthews came along and proved that toast falling off a table isn't flipped at all, it slides. Here's exactly how it plays out. Step 1. The toast overbalances over the edge of the table. Step 2. This off-center fall allows gravity to induce a torque, which gives the toast a rotational spin. And step 3, given the average height of a standard table, the toast rotates exactly 180 degrees, just a half turn, before it hits the floor. Matthews actually won the 1996 Ig Nobel Prize in Physics for this mathematical proof. It's brilliant.
And his math brilliantly illustrates the real-world data too. In 2001, Matthews put his theory to the ultimate test. He organized this massive study involving around 1,000 school children across the UK, and they performed exactly 9,821 documented toast drops. The result? A whopping 62% of the time that toast landed butter side down. 62%! So it definitively proved that this isn't just you having bad luck. It is undeniable, mathematically proven physics.
Now you might be wondering, why on earth is a table exactly the right height to cause a half rotation in the first place? Well, Matthews demonstrated that the universe is literally configured for your toast to land face down. Think about it. Human height dictates table height, right? And human height is structurally bounded by 3 fundamental constants of nature. We've got the fine structure constant, which dictates the chemical bond strength of your skull, the gravitational constant determining the impact force of a fall, and the Bohr radius establishing atom size. If we were taller than, say, 3 meters, a simple trip and fall would fracture our skulls. So human height, and therefore table height, is strictly bounded by the physical limits of the universe, perfectly timing the tragic 180-degree rotation of your breakfast. Mind-blowing, right?
But let's step away from the breakfast table for a minute and head into Section 2, the true origin story. To truly appreciate Murphy's Law, we really have to look at United States Air Force Project MX-981 and the extreme life-and-death origins of the law itself. This timeline maps it out. From 1947 to 1949 at Edwards Air Force Base, a highly rigorous research program was testing human physiological tolerance to extreme deceleration forces. Basically, they were trying to figure out exactly how much G-force a military pilot could survive in a high-velocity crash. Leading this wild charge was a pioneering flight surgeon named Colonel John Paul Stapp. Stapp would literally strap himself into a vehicle called the Gee-Whiz rocket sled, and to gather data, he subjected himself to brutal slamming stops pulling up to 40 Gs of deceleration force. The physical toll on him was just immense. We're talking broken ribs, concussions, hemorrhaged retinas. So to accurately measure these insane forces, the team brought in a developmental engineer from Ohio. His name? Captain Edward A. Murphy, Jr. So Captain Murphy brought in these electronic strain gauges to measure the G-forces, but during a test run with a chimpanzee, the sensors completely flatlined. They read 0. Turns out all the sensors had been wired completely backwards, so they literally canceled each other out. A super frustrated Captain Murphy blamed the technician, and he famously complained, "If there is any way to do it wrong, he will." But Colonel Stapp took that complaint and absolutely transformed it. Days later at a press conference, Stapp credited their incredible safety record to Murphy's Law. He explained that by assuming things will go wrong, they were forced to proactively design life-saving safeguards. So while Murphy was just complaining, Stapp was actively engineering.
That brings us perfectly to Section 3, Wired for the Negative. Let's look at the psychology here. Because if the physics and the engineering of our world are so highly rational, why do our brains insist that the universe is maliciously targeting us? Well, it all starts with negativity bias. This is a deeply ingrained cognitive phenomenon, an evolutionary survival mechanism. Thousands of years ago, our ancestors literally had to prioritize threat detection to stay alive. Missing out on a sweet berry was just a missed lunch, but ignoring a rustling bush, that meant getting eaten by a predator. So our brains are quite literally hardwired to feel the pain of a negative event far, far more intensely than the joy of an equally positive one.
Psychologists Paul Rozin and Edward Reisman actually broke this bias down into 4 distinct elements. First, negative potency, meaning a bad event just inherently feels more intense. Then steeper negative gradients. That means the absolute dread of an upcoming bad event grows much faster than the excitement for a good one. Next is negativity dominance, where just one bad element can completely ruin an otherwise great situation. And finally, negative differentiation, which means our brain spends way more processing power analyzing negative events. This is exactly why a relatively minor mechanical failure or, dropping your toast feels like a monumental cosmic disaster. Your brain is literally amplifying it.
And that brings us right to the second psychological culprit, confirmation bias. Formulated by Peter Wasson, this is the automatic habit of searching for and recalling information that confirms what you already believe, while completely ignoring contrary evidence. It's like, if you believe you have terrible luck, your brain automatically acts as a selective filter to prove you right.
There is rigorous academic research into the deep roots and mechanics of confirmation bias, showing exactly how it dictates our reasoning. When we hit a string of bad luck, we stubbornly defend our pessimistic beliefs. We literally reconstruct our memories to favor the times things broke, the times the checkout line was way too long, or the times the toast fell butter side down. And in the process, we completely erase all the times things went perfectly fine. So, when we put all this together, we see a really stark contrast. The reality is just a series of disconnected, statistically predictable failures. A sensor wired backward, or a piece of toast sliding off a table bounded by universal constants. But the illusion, which is totally crafted by our negativity and confirmation biases, weaves all those random moments into a cohesive narrative of cosmic malice. We literally convince ourselves that Murphy's Law is some kind of supernatural force, rather than just physics and psychology working in tandem.
So, the absolutely crucial takeaway here is this. The universe isn't actually out to get you. It's just adhering to its own physical rules. Next time your toast falls, I want you to ask yourself, are you just remembering the drops and completely forgetting all the times you caught it? Thank you so much for exploring the fascinating truth behind Murphy's Law with me. And as explainer, keep questioning, keep analyzing, and hey, try to catch that toast.
Until then, take care.